Welcome back, 6th graders. Today we're going to be taking a look at quadrilaterals. By the end of this lesson, you want to be able to classify quadrilaterals and find the missing angles inside of a quadrilateral. So a quadrilateral, if you listen to the word quad, kind of gives it away. A quadrilateral is a figure with 4 sides and 4 angles, and the sum of the measures of the angles of a quadrilateral is always going to be 360 degrees. Which means here we have a quadrilateral because there's 1, 2, 3, 4 sides, 1, 2, 3, 4 angles. So that means that x plus y plus w plus z equals 360 degrees. So using that information, if you want to go ahead and pause the video and try these two on the bottom, see if you can find the missing angle measure. So this is much like what we were doing with the triangles. So 70 plus 65 plus 95 plus x needs to equal 360. So I would combine 70, 65, and 95 to give us a total of 230 plus a number equals 360, which is the same thing as saying 360 minus 230 is equal to x. So if we do that, we get a value of 130 degrees equals x. Alright, which obviously doesn't go along with what the picture is, because if you look, that should be an acute angle and this one should actually be bigger. But once again, you have to use what they give you as the information and not necessarily what the picture looks like. Alright, so let's try the next one on our own. So we have 85 plus 146 plus 75 plus x equals 360. So once again, I'm going to combine my angle measures. 146 plus 85 plus 75 gives us 306 plus x equals 360. So I'm going to do the 360 minus 306, and I get x equals 54 degrees. Now, like triangles, quadrilaterals can also be classified in different ways, and there are 5 basic quadrilaterals that are specific beyond just being a quadrilateral. The first and probably one of the most familiar is a rectangle. A rectangle has opposite sides congruent, which means, remember, they're the same. All angles are right angles, and opposite sides are parallel. So if we had a figure, it would look something like this. So each angle is a 90-degree angle, so each one gets a box. Opposite sides are congruent, so remember those little tick marks means congruent. So here, the 2 designate that these 2 are congruent, and the 1 on these designate that those are congruent. Alright, what about a square? Well, remember, a square means all sides are congruent or equal. All angles, once again, have to be right angles, and opposite sides are parallel. So here, we just put 1 tick mark on each one, and then we'd also have our little squares in the corner to show that they're 90-degree angles. One that you're probably familiar with, but probably not as much as the previous 2, is a parallelogram. In this one, the opposite sides again are congruent. Opposite sides are parallel. That's the parallelogram. And opposite angles are congruent. So no longer are they 90-degree angles necessarily. So here, this side is congruent to that. The bottom is congruent to the top. Opposite angles are congruent. So these little arcs can mean congruent too. So if you look here, 1 arc, those 2 are congruent. 2 arcs, that those 2 are congruent to each other. Alright, a rhombus means all sides are congruent, kind of like a square. Opposite sides are parallel, and opposite angles are congruent again. So if you look, a parallelogram is basically a tipped over rectangle, and a rhombus is a tipped over square. So all sides are congruent, and then opposite angles are congruent again. Okay. The last shape, which is most different from all the rest, is a trapezoid. And the one thing with the trapezoid is that it has exactly one pair of parallel sides. So in this case, the top and the bottom are parallel and the sides are not, because if we continued those on, so it's kind of like a triangle with its top chopped off. Now we're going to look at some just some classification stuff. So at the top of our pyramid, and actually it should probably even be at the bottom, quadrilateral is any side with four shapes, or any shape with four sides. So anything that has four sides that's closed is a quadrilateral. Then from a quadrilateral we can get a little bit more specific. Our shape can be a parallelogram or a trapezoid. Now if you look at this side of the tree, trapezoid is all by itself. So if it's a trapezoid and a quadrilateral, but it is nothing else. So every trapezoid is a quadrilateral, but not every quadrilateral is a trapezoid. From parallelogram, you see our family tree gets a little bit bigger. A parallelogram could possibly also be a rhombus or a rectangle. Now, it can't be a rhombus and a rectangle, and it can't be a rectangle and a rhombus, but it could be a rhombus and a parallelogram or a rectangle and a parallelogram. Now, the weird thing about this is that our last shape, a square, can actually feed into either of these other ones. So a square is a rectangle, a square is a rhombus, a rectangle is a parallelogram, and a rhombus is a parallelogram, and a parallelogram is a quadrilateral. So it's kind of this funny family tree that whatever's above it, it is part of. So a square is a rhombus is a parallelogram. Kind of a messy little family here. Alright, so we're going to use those rules to classify each quadrilateral. And generally we're going to classify it as the most specific, but we'll also talk about how it is actually some of the other ones because it meets the standards. Okay, so if we look at this first one, we have 4 right angles and 4 congruent sides. So since it has 4 right angles and 4 congruent sides, its most specific classification is a square. And that's basically usually what we're looking for. But for your information, if it is a square, because it has 4 congruent sides and parallel sides are opposite sides are parallel, it is also a rhombus. Because it has 4 right angles and opposite sides are congruent, it is also a rectangle. And because it's a rectangle and a rhombus, it's also a parallelogram. And because it's a parallelogram, it is also a quadrilateral. Typically what we're looking for is just square, but it is actually all of these other things as well. Now this next one might look a little confusing. These little triangles, usually they're just like little arrows, but I couldn't get them on the slide, mean that these sides are parallel to each other. So here we have one pair of parallel sides, so this would be a trapezoid. And because it's a trapezoid, it is also a quadrilateral. But trapezoid is really what we're looking for. Okay, on this next one, we can only take the information that's given to us. So a lot of you might want to say, well, it's a rectangle because it looks like a rectangle. But because there are not squares in the corners, we can't assume that they're 90-degree angles. So then we have to just use the information that's given to us. Opposite sides are congruent, which means that their opposite sides are also parallel. So we could only classify this one as a parallelogram. Even though it really looks like a rectangle, because there's not the 90-degree angles in the squares, we can't classify it that way. Because it's parallelogram, then again, it's also a quadrilateral. I know the classification stuff can be a little bit confusing, but just remember you can only use the information that is given to you. If you have any questions, make sure you let me know.